the following 7 questions. Alpha, this is delta x, y, beta, z, y. I don't know what the symbol is, and this is, I guess, epsilon. So they are dash carbon atoms in the parent chain and it is called dash. So if I remember correctly, the parent chain is the chain having the most number of carbon atoms. So if I just count 1, 2, 3, 4, 5, 6, 7, 8, 9. I can count 9. 1, 2, 3, 4, 5, 6, 7, 8. This is 8. 1, 2, 3, 4, 5, 6, 7, 8. Again 8. 1, 2, 3, 4, 5, 6, 7, 8. Again 8. 1, 2, 3, 4, 5. Okay. So I can count 9. So there are 9 carbon atoms. Okay. And this is called, since it is all single bonded, and the single bonded molecules are called ane. Dec is for 10, so I'm guessing the answer should be 9, non-ane. Numbering of this molecule will begin at which carbon? Okay, so 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4. So this is the longest parent chain, and the side chain on the branches, they are close to this epsilon instead of alpha. So I'm guessing that epsilon should be a closer guess. I mean, like, it's just logic. I don't know if this is correct or not, but still. Use the following information along with the previous diagram to answer the following questions. Consider the possible branches at carbons x, y, z. So the branches at y are called. So y, okay, and this is that, and we have to know that what are the branches at y are called. The y branches, that basically means that this particular branch. So this is meth, eth, and prop. So I'm guessing it should be propyl. Yes or no? This is the main parent compound or the parent chain, and this is the side chain or the branch. So I'm guessing propyl is the correct answer. Which carbon can only make one or more bond? Okay, so this is XY, YZ, and XZ. Which carbon can make only one more bond? So X, it is connected to 2 carbon atoms, so it can make 2 more. Z and Y, they are basically the same. I mean, like, it is connected to 3 carbon atoms, so it can make 1 more. The same goes for Z. That is, it is connected with 1, 2, and 3, so it can make 1 more. So I'm guessing the answer should be Y and Z. Which carbon? Okay, that is X, definitely. I just said that since X is connected to 2 carbon atoms, it can make 2 more. What is the IUPAC name of the compound? Okay, that is a little bit tricky, but 1, 2, 3, 4. So I'm guessing 4 methyl. 1, 2, 3, 4. 4 methyl 5. 1, 2, 3. 5 propyl. I'm guessing the spelling is correct here, propyl. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Non-ane. 4 methyl 5 propyl, non-ane. Is this alphabetically correct? I'm guessing so. Or is it number? I mean, like, it doesn't really matter in this case. So the addition of a methyl group onto the carbon dash and dash would add an extra side chain. Okay, so alpha, no. The delta and eta, delta and this. Okay, so adding delta, yeah, it would definitely create a, not eta. I guess this should be the answer. Okay, let's just move on. Which of the following is not an organic molecule? I have no idea. Eeny, meeny, miny, mo. Let's just say carbon dioxide is not an organic molecule. I know organic molecule contains carbon. Methoxide. I don't know what the formula for methoxide is, so I'm just gonna make a guess. How many valence electrons are present in the methane? Okay, so for methane it is CH4. For methane it is CH4, and carbon, it contains 4 valence electrons. For hydrogen it contains 4, so 4 and 4 is gonna be 8, I'm guessing. Which element has the same number of electrons as methane? Okay, so 8 is oxygen. Okay, next. Which of the following functional group is most likely to taste sour? Okay, this is ROH. I know OH is alcohol, and alcohol tastes a little bit sour. COOH is carboxylic acid. Dash H is halide, if I remember. Haloalkanes, yeah, haloalkanes or halides, I guess. COOR dash is, I guess, called, I don't know what was it called. I'm just gonna make a guess of ROH. Can you? I have no idea. That's why it tastes so bad. The molecule with the lowest boiling point. Okay, still I have no idea. But okay, so just a random guess. CH4 is alkane, but every other has some functional group. This is COH, so this is acid, carboxylic acid. This is COOCH3. I am guessing this is ether or ester, whatever is called. This is haloalkite, so this is the only one that is left. I mean, like, it's a pure, so I'm guessing that that should be the answer. So how many hydrogen atoms does an alkane with n number of, okay, alkane, alkane, alkene, alkyne. So alkane is 2n plus 2. Next. So use the following information to answer the 5 questions. So this is diethyl ether. Okay, so which of the molecule can take part in dipole-dipole interaction? No idea. What is dipole-dipole interaction? I know what is dipole, but how do we find that which molecules can take part in dipole-dipole interaction? So I'm just gonna go with this. Okay, let's make a guesswork. Then for the next question, assume each substance is a liquid at room temperature. First off, which of these molecules can mix with CF4? Diethyl ether. No idea. Okay, this is ether. This is methyl cyclopentane. This is methanoic acid, and this is decanoic acid. Okay, so just a random guesswork that this is ether, again a functional group. This is acid, again a functional group. This is acid, again a functional group. However, this is the original haloalkane. Not haloalkane, this is the original alkane. So I can make a guess for this. Why can they mix with CF4? I have no idea. But still I'm just gonna write because it is a alkane. Or can I write pure alkane? Because the rest everything is a mixture of functional group. This is ether, this is acid, and this is again acid. Despite the methanoic acid has much fewer carbon atoms than methyl, its boiling point is much higher. I like this word, hydrogen bonding, so I'm just gonna add this hydrogen bonding. Where would you expect propanol to be? Propanol. Propanol. All. I'm guessing it is a alcohol. So where can I place alcohol in this? Let me see. Ether, pentane, acid, acid. So I have no idea. Alcohol, they generally, I know, like methanol, or sorry, or ethanol. It has a lower boiling temperature than water. So I'm just gonna put it between this methyl cyclopentane and methanoic acid. Methyl cyclopentane and methanoic acid. Okay, that's just my guesswork, and yeah, let us move on. Okay, so there's yet another test. So the addition of a methyl group to which carbon would not produce a side chain? Alpha, no. Beta, no. Gamma, no. Huh. It would not produce. All of them will produce a side chain. Either you add it over here, or you add it over here, or you add it over here. So this is again the longest chain. Over here again the longest chain. Over here again the longest chain. The addition of a methyl to which carbon would produce the same molecule? Methyl. Since alpha and gamma, they are almost identical. I mean, like, if you count from here, so alpha is 2, and if you count from here, alpha, gamma is 2. So I'm just going to go with alpha and gamma. How many valence electrons are present in this molecule? So 1, 2, 3, 4, 5, 6. 6 carbon means 6 fours are, I mean, like, each carbon can contribute to 4 valence electrons. So 6 carbon means 6 fours are 24. So 24 carbons, and this is 3 hydrogens, 2, 2, 2, 2, and 3. 3, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14. So 14 electrons plus 1, 2, 3, 4, 5, 6. 6 fours are 24. 14 and 24, if you just add that, so that becomes 38. Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so I guess I am right. What is the maximum number of propyl group that can be added to carbon alpha? So alpha is connected with 2 carbon atoms. That means it can bond with 2 more if required. So I'm just gonna go with the answer, that is 2. I don't know whether this answer is correct or not, but I'm just gonna make a guess. Next. The electrons in a benzene ring are not fixed on one atom. They are in resonance. I mean, like, electrons are in resonance or decentralized or delocalized. Like, I know that electrons in a benzene ring, they move from one carbon atom to another carbon atom. So they are delocalized. Yes. A natural dye has been discovered. It is bipolar. It does not have any natural odor or color without the presence of another chemical. In the lab, you are presented with 5 vials that may contain polar. Okay. will you attempt to detect its presence? No, since it is neutral, so I mean definitely past it will originally have 7 and adding that, so it will decrease that. It is a polar compound. I know that polar compounds, they are soluble in water, so let's just add this or select this. Okay, so let's just try to submit it. Okay, so let us view our scores. Okay, it is 16 points out of 25. That's pretty good. So okay, so this is correct, this is correct. Okay, methyl ethyl. Why? Meth, eth, 1, 2. No. Okay, I have no idea why this is the answer. Okay, this is correct, this is correct. Come on, this is almost the same. I have to add one dash over here. Okay, and the addition of a methyl group onto the carbon would add an extra side chain. That is correct, that is correct. This is correct. I have no idea, not a clue. Hey, it's a guesswork and it is correct. That's good. How many hydrogen atoms does an alkane with n carbon atoms have? It is okay. This is 10. Okay, I have no idea with this. Okay, again a guesswork. That is correct. But hey, this is not a guesswork. I mean, like, almost a guesswork. London decisive forces. Okay. Okay. So, methanoic acid can participate in hydrogen bonding. Okay, this is correct. Why would all produce the same molecule? This is at number 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2. 1, 2. I have no idea with this. Delocalized. Oh, come on, it's a spelling mistake. Okay, so that is the result. Now let us see what we have to do next. Okay, I have given the test. Take a 5-minute break. I actually do not need that, but I still have some time left, around a minute, but we can move on. Guide repeaters, please ensure that you are talking through. Okay, definitely I'm talking. So for the first 30 minutes of your tutoring session, use the assigned model to the best of your ability to increase your understanding. If you do not get through everything by the end of the 30 minutes, move on to the next section anyways. Alright, so now my time begins. I'll just reset this. I will bring it to 30 minutes. Since it is asking me to test it to best of my abilities, so I'm just gonna do this. Paste the given molecule, give it to ChatGPT, and then ask it that what are the branches at Y called. It is thinking. It is thinking. Okay, it is importing the image, and still it is thinking. Again thinking. Okay, it's taking quite a lot of time. Okay, now it imported the image. It is still thinking, it is taking quite a lot of time. It is still thinking. Thinking quite a lot. It is still thinking. It's been over around 5 minutes. Still thinking. Okay, so it is saying that an issue or an error has occurred. So I'll just try again. I'll just try again and ask it to do the same. It seems that we have 3 hexagon fused. They are not proper hexagons, but still. It is still thinking. It's been around 7-8 minutes. It is still thinking. It is still thinking quite a lot. It is still thinking. It is still thinking. It's been over 10 minutes. Okay, finally it gave me an answer. So let us just try. They are alpha, beta, and explain include and to history. Let's try one lot more, one lot of chemistry. still it is thinking and thinking and thinking. It's thinking quite a lot. First of all, start counting from A, B, C, alpha, beta, gamma. But the answer it was something else. The answer methyl ethyl. Let's see if it can. Still thinking. I'll just all everything that sticks out of the parent chain of branch, assuming that is correct. Choosing the parent chain one comes upon the most convenient chain is the one that's next the left and then bottom right it runs. Okay, it starts from beta 1, 2, 3, 4, 5, 6, 7, 8. But no, it is only 8. Number 2 said it is only one carbon Z itself before the chain continues, one methyl. Upward through X delta there are two new carbons X and delta before reaching the upper end of the ring which is in the parent chain. Huh. 1, 2. I have absolutely no idea what it is talking about. But still, I can ask some different questions. Okay, this was almost correct. This is almost correct. So, which of the following functional group states are? I can ask this. And I'll just add these. And also, let me ask the reasoning why. Also, explain the reasoning. So let's just see how these things work. A carboxylic acid. Okay, why? So a carboxylic acid goes from the free hydrogen ions. Okay, carboxylic acid easily let go of H plus ions from the OH group. Okay, okay, classic. Okay, vinegar acid, citrus acid, yogurt, and all the molecules of this with COOH group. Okay, so the alcohol is very weak acid, hardly any free hydrogen plus ions. Okay, since alcohol is weak acid, so it cannot give H plus ions. Neutral, sometimes slightly sweet or warming. Think ethanol. Okay, ester or COOR. That means that a pleasant fruity aroma. Okay, so the fruity aroma is from this. Alkyl halide, no characteristic food, like often pungent and irritating. Okay, so this irritating. So COOH is sour due to the free hydrogens. Alcohol, just like alcohol, neutral or sometimes warming. Alkyl, it is irritating and pungent. This is banana, like a fruity aroma. Okay, so can you answer the previous one, and why and why not? Okay, let's just ask Gemini this question. Not Gemini, ChatGPT. Yes. OH hydrogen, this is a hydrogen bond down, another hydrogen attached to a very electronegative oxygen, so its electron density is pulled away, leaving it slightly positive. It can reach out to lone pair for the electron. Okay, both oxygens, both the carboxylic oxygen and hydrogen oxygen acts as hydrogen bond acceptor. Each oxygen has one lone pair electron that are slightly negative and can accept donor hydrogen from another molecule. Two carboxylic acid molecules form a cyclic dimer. Each donates one hydrogen bond and accepts, creating a pair which is needed for hydrogen bonding. Okay. So in alcohol they act as donor, in carboxylic, in ether, S or ester, they act as acceptors. However, in the carboxylic acid they act as both. Alright, I'm like, that's fine. Which molecule will have the lowest boiling point? Okay, yeah, this is important, and I need to ask why, because that was just a guesswork. I'll also be asking the reasoning behind the same. Okay, so the methane has lowest boiling point out of the four. Reason it is higher or lower? So only weak London dispersion forces. Okay, so there's something called London dispersion forces. CH3Cl molecule has London plus moderate dipole-dipole interaction. Methyl formate has London plus dipole-dipole interaction. It has dipole-dipole and hydrogen bonding. Okay, so hydrogen bonding and dipole-dipole interaction, they increase the boiling point, However, having only London forces, they decrease. Okay, now let me ask, what are London dispersion forces? Because of the intermolecular forces attraction, they can pull neutral molecules towards each other. Every atom whose average charge is balanced, still for a fleeting instant they may bunch up. Okay. Temporary dipole moment, because it lasts only for a split second, we call it instantaneous dipole. Okay. Instantaneous dipole includes dipole next door. The result is it is always present between whether they are polar or not. Okay, so it is present in all the molecules. Next, it is very short-lived and weak compared to the hydrogen bonding or a permanent dipole-dipole force. Okay. Factors affecting. Okay, it should have greater surface area, more electrons, or closer proximity. Okay. Boiling point, noble gas. So as the dispersion forces grow with size. Butter versus oil, long saturated fans chain stack closely, adding a lot of dispersion forces and solidifying at the room temperature. Short and lean cannot. Okay, so they stay liquid. Let's set out with stickiness. Okay. So list the factors that London forces depends upon in short. I still have 6 minutes left. I can ask this question next. More electron, higher overall, closer intermolecular approach. Okay, I guess this should be more than enough. And this is, I just add this and send it to it. So more electrons, greater surface area in contact, closer intermolecular, and higher overall polarizability. Okay. So dipole-dipole interaction occurs between polar molecules, and these contains bonds to a very electronegative atom arranged so that a permanent molecular dipole results. So polar, non-polar, strongly polar, and polar. So that means that polar molecules, they have high, no, it is non-polar, it is polar, no permanent dipole. Since diethyl, it is polar, why did it has diethyl? Okay, so polar molecules can, that means that if the atom contains an electronegative atom, it can have dipole-dipole interaction. Okay, why, what is this? Diethyl ether, diethyl ether has lower boiling point than methyl cyclopentane despite having a dipole moment. I mean, like, since 1, 3, and 4 they are polar molecules and have some dipole moment. So why do this has more boiling point? Okay, because boiling point is a tug of war between all the molecular forces, not just dipole-dipole. So permanent dipole, yes. Ability to bond hydrogen, no. None. Okay, this has more electron count. Molecular shape, short, rigid, ring plus compact. Okay, so London forces, it has more London forces, and the shape matters. Branched or floppy molecules like diethyl ether cannot pack as tightly. Okay, so since London forces are stronger, that means that they will have a greater boiling point. Okay, that makes sense. I can ask this question since it was a guesswork. It is still thinking. The time is almost over. Still thinking. Still thinking. And still thinking. The time is up. Okay. I'll just stop this and I'll just move on to the next task. So ask the model these questions. What are the IUPAC rules for naming the chain of alkenes? Okay, but I'll just wait for it to stop. In the meantime, I'll add the timer that is for 15 minutes. I'll start that once this is done. It is still thinking. is still thinking. I'll just stop this. Let's start the timer for this. Still thinking. It is taking quite a lot of time. It is not. Okay. This is not the question that I asked. If I asked a different question, but it is like okay, so it is giving the two responses. But since the time is over, I will be looking only at this. Okay, so it is still coming. So this is math at group and add a n to show add e. Next, I'll ask the next question. Carboxylic acid and aromatics. So C1 to C4, like methane, ethane, propane, butane. Yeah. From ethane. Yes. Water soluble. Like no, that is alcohol. Sorry. So water profile, a little kerosene like ester, smell, sweet smell, fruity smell, carboxylic acid, sharp, pungent smell, aromatic, distinct, solvent. Okay, smell paint. Okay, paint thinner. Okay, water solubility completely miscible. Okay, so only carboxylic acid till C4. Since they are polar, so that's why they can. Okay, London forces intermolecular. Only London forces alkanes. This should have another one, motor dipole, and pi pi. Key takeaway, okay, polarity rules their behavior. Alkanes and alkanes are non-polar, low solubility in water, rely on dispersion forces. Okay, esters are moderately polar, so they can be soluble. Highly polar, so they are water soluble. Otter Qs are powerful mnemonics. Okay, fruity ester, sour vinegar, acid, fuel like alkane aromatic. Okay. Chain length overrides family once it gets long enough. Very long ester or acid becomes waxy solid. Okay, this was just the case where it said regarding oil and butter. So these parent patterns let you make a quick prediction about the unfamiliar behavior. Okay, cool. Let us ask another question. The length, the area, the size, and the polarizability. So total number of electrons here, area, yeah. So if is long and branched, then net forces can be created. As iodine is present. Conversely, small hydrogen bond capable molecules, water, ethanol, formic acid stay at the top of pyramid. Small size, energy holds to very large size. So the compass, it is the least correspondent potential would have an enough point that it can dominate. Okay, that makes sense. Next, the start. Okay, I actually did it. That changes how closely and for how long two molecules can touch, will change the total relief. So why LDFs differ? Branching makes molecule more compact. A compact will give less surface area, so they will decrease definitely. Conformer of the same isomer, even within one isomer, are stressed all anti-chain molecules with more contact. In a liquid, the population shift towards the lower energy conformations or average LDF changes. So if I have to just take a key away, that is two molecules need only differ in how much their electron clouds can press together through branching, folding, and different spatial arrangement for their London dispersion forces. Thus, okay, so what I'm understanding is if the molecule if the molecules have same molecular formula but different structure, so the one having the greater area will have greater LDF. Yes. Copy, then let us just paste it. How do I count valence electrons in an alkane? By looking at the carbon skeleton. So quick rule for any alkane CnH2n plus 2, the total number of carbon or valence electrons is 2. Alkane, plug in the counts 6n plus 2, that makes sense. How to use it at a glance? Count carbons in a skeleton drawing. Each line or a vertex without a label equals 1 carbon. CH3. So that basically means that you have to follow the formula 6n plus 2. But or I'll just follow this. That is, each carbon contributes 4 electrons and each hydrogen corresponds or contributes to 1 electron. Next, how can titrations be used to identify molecules? So a titration tells you how many moles of unknown reagent are required to react completely with an unknown molecule. Okay. What can you learn from a titration? What do you measure during after titration? Stoichiometric ratio at the equivalence point. Okay, what is this? Color change, presence or absence of a group of an ion. Okay, I'll just read this since I'm unable to understand the things that are written. So the right titration, acid-base redox perception, record the exact volume and concentration of the titrant used, monitor the curve, calculate the molar mass. I'll just ask it. Explain it to me in simpler terms. I am very into chemistry. Titration. You're slowly a liquid you know, the titrant, to a liquid you don't know, you're simple. Okay. You watch for a clear signal that to have completely reacted on a sudden color change or a sharp jump on a pH meter scale. Okay. This is called the endpoint. Why the last few drops matter? Because you have to measure exactly how many milliliters of the millilent were used, of the titrant were used. Since you know the titrant's strength, its concentration, now you know how many moles reacted. From the recipient stoichiometry, you can figure out how many moles of the known is for your beaker. Okay. Acid-base titration. Drop any a strong base into a known acid until the flip color A to B. Redox titration. Trip purple KMnO4 potassium manganese oxide, I don't know. When one drop stays purple, you are done. Putting the clues together, size, molecule. Add any special pH or color behavior. Mix these clues with the reference table. You can often name the unknown or at least cut the list to 1 or 2 likely molecules. Okay, so for the next part, in short, a titration is like counting how many spoonfuls of antidote you need to neutralize a mystery poison. By knowing the spoons you used and how they reacted, you can work out how big the poison molecule are and how many dangerous parts they have enough. Okay, so I guess more or less my time over here is complete. Now I will ask or actually give the PDF, or I will download this and give it to the chat GPT to make a 10-minute questions for me. Okay, now what do I have to ask? That is generate 10-minute worth of MCQs on this file. Okay, I'll just copy paste this and I'll just ask it. I'll just ask it and okay, so it is generating the MCQs from the PDF file, and okay, here's a chat for I'm going to give approximately 1 minute. So it has given me approximately 1 minute for each MCQ and 1.5 minutes for each short answer type. So for the parent chain, okay, parent chain, then a skeleton alkane has 9 carbon atom in a straight line with 1 ethyl substitute on C4. What is the correct meth, eth, prop, but? It should be nonane, right? Since and for the second valence count electron C5H12, so each carbon atom it corresponds to, or it gives 4 valence electrons. That means 5 4s are 20 and plus 12, so 32. That means A. Next, and which pair of molecular forces can interact only through London dispersion forces? So London dispersion forces, they are present in each and every molecule which do not have an electronegative atom or dipole-dipole strength. So electronegative chlorine is electronegative, CH4 and N-hexane. So each and every other group has electronegative atoms except for part B. So that's why I'm going to mark part B. Boiling point comparison. So for point 4, rank these from the lowest to highest. So butane, all, okay, acid. So greater the hydrogen bonding and the dipole strength, greater will be the boiling point. And out of alcohol and carboxylic acid, if I remember correctly, the carboxylic acid has a greater dipole-dipole strength. That means it will have a greater boiling temperature. So 1, 2 and 3. I'm gonna go with A. For the fifth miscibility, CH4, which of the following substance would you expect to be immiscible with the CH4 at minus 100 degrees Celsius? So CH4 is a non-polar substance, and so it should, the one that is to be added should be a polar substance. So ethanoic acid, it has a dipole-dipole strength. That means it is a polar substance. So the answer should be C. Functional group taste. Taste sour. If it is sour, then it is carboxylic acid. D. 7. Explain in 1 or 2 sentences why I do boil at 100. Okay, so iodine molecule has greater electron cloud, which results in greater London forces. Hence, it boils at higher temperature than methanol. Number 8. Symmetry and side chains. So cyclohexane, carbon, alpha and gamma are related by a mirror plane. I cannot actually see, so page 5. So it is asking me to generate page 5 alpha and gamma. Alpha and gamma, page 5. Where is that? Okay, yeah. So related by mirror image. If you add the two, they will be the same since the numbering will begin. The numbering for naming of IUPAC will begin near the carbon atom where the branch is added. Number 9. Write the general molecular formula for a straight chain molecule of the monocarboxylic acid containing n number of n carbon atom. Okay, so C N C O O H. So can I just write it as R? For the question 10 detection, you are given question 10 you are given 5 clear odorless liquids. One is neutral polar dye described as on page number 6. Okay, and outline the simple steps procedure other than adding water that you would like to let your dye sample from the known polar and explain why it works. For this I have no idea. Let's just see how did I perform on the test. Come on. Okay, second is wrong, so 44. Okay, right, that's what I did. Mostly correct. Good idea. What it needs to be partially correct. Okay, that should clear. Nice work overall. Okay, thank you. So this is done. Then what I need to do, take a 10-minute break. I don't need it. Post test, so I need to do a post test, and my post test is this. Record next. Okay, so 1 2 there are dash carbon atoms in the parent chain. It is called dash 1 2 3 4 5 6. So I can say 6 if there are 6, so 6 and hexane. That is correct. Numbering will begin at, since there are two molecules connected over here, so I'm guessing the numbering should begin with alpha. Next, the branches at X are called methyl, meth, eth, prop, so cyclopropane, methyl and cyclopropane, propyl. Okay, cyclopropyl. There is a type of branch that is common between carbon X and Z. What it is called? Next, X and Z. Okay, so this is called methyl. Which carbon atom is able to make another bond? So X is already bonded to 4, Y is bonded to 3, Z is bonded to 4, so Y can make another bond. IUPAC name for the compound 1 2, so 2 methyl 2 propyl, cyclopropyl, 2 methyl 2 cyclopropyl, 1 2 3 meth eth, 3 ethyl meth eth prop but, 4 methyl, actually dimethyl, for dimethyl hexane. The addition of a methyl group into carbon would cause a change only to the parents, so only to the parent. So that should be, I mean, like adding at alpha. So 1, 2, 3, 1, 2, 3. Like we could add at alpha. So 1, 2, 3. This is 3. This is 1, 2, 3. So this is 3. So okay, I'm just gonna go with that. Organic molecule, I have no idea. Benzene is an organic molecule that I know about. Let's say tetrabutanoxide. How many valence electrons are present in the butane? So meth, eth, prop, but. So butane is 4 carbons. So meth, eth, prop, but. So CH3, CH2, CH2 and CH3. So 4 carbons, that means 16, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. 10 plus 6, 26. So, or again use 6 and plus 2. So 26. Sakti, Vekarman, Ficoni, Kuchan, Ficoni, Fe, iron. So the same element or the atomic number of iron is 26. Has a pleasant sweet smell. Sweet smell is, I guess it was ester. Can you answer the previous question in the hydrogen bonding terms? No. I'm like, ester can donate hydrogen ions but cannot accept them. This is one of the possible answers. Which molecule will have the highest boiling point? Okay, so highest boiling point means greatest dipole-dipole interaction. That is the most in carboxylic acids, COOH. Alkene, alkane, alkene, alkyne. Alkene is 2N. Okay, so which molecule has London dissipation forces are present in all of them? Is which of them can mix with water? So that has to be polar molecule. It has to have a electronegative atom in it. So this has, this does not have, this has, this does not have. So heptene and ethanoic acid. Okay, that is not the option. Ethanoic acid, it can. Ethanol, it can. Yeah, ethanol and ethanoic acid. Why they can mix with water? Because they are polar molecules having an electronegative atom. Despite that, decane does not have a permanent dipole. Its boiling point is unstable. No, I mean, like, one of the probable reasons is it has higher LDP or LDFs. Where do you expect methanol? So methanol should be, methanol, since it is alcohol, it should be greater than this. Eth. No, methanol. It has less carbon atoms, so it should be above ethanol. Above ethanol. I'm just making a guess. Next. That would not produce, no, a side chain. All of them will produce a side chain. The addition of a methyl to which carbon would produce the same molecule? If I add methyl over here or over here or over here, they will all produce the same. How many valence electron in this molecule? 1 2 3 4 5. 5 carbon atoms, that means 20, and 1 2 3 4 5 6 7 8 9 10. So that means 30. 1 2 3 4 5 6 7 8 9 10. So 30. What is the maximum number of propyl groups that can be added to the carbon alpha? 2. Since it is bonded to two atoms, two carbon atoms, so it can also attach itself to two more. Next. The electrons in the benzene ring are not fixed on one atom, they are delocalized. And acidic flavor, okay, since compound has been discovered, it is naturally dissolved in an organic solvent, that is, it is non-polar. It does not have any natural odor or color. In the lab you are presented with 5 vials that may contain flavor compound. How will you attempt to detect its presence? So since it is acidic, adding acid does not help. Adding water does not help because it is non-polar. I'm just gonna go with NaOH since it is acidic. NaOH is a base, so it will help us neutralize the solution. That makes sense. Let us just see the results. Okay, so 20 out of 25. This is correct, this is correct, this is correct. Okay. 2 cyclopropyl. Okay, this has to come here. Okay, trimethyl. Okay, so more or less, yeah. Hydrogen cyanide, HCN. Okay, this is correct, this is correct. No, they are not bonded. Okay, all of them, because I'm like, that is more or less correct answer. It can contains the most carbon. Okay. Okay, this is correct, this is correct, this is correct. Alright, so what's the next step that I have to do? Final surveys, please complete both the surveys. These are not available. ChatGPT. Yes. Next. Oh, it was quite demanding having to sit. Again, 9. How hurried or rushed was the pace of the task? It was fairly average. I was quite good. Actually improved. How did you work to complete the yoga? I did quite a lot of effort. No, I wasn't annoyed that much. But still, I'll give it a fair 6 because... Okay, thank you. And for this, I use ChatGPT. I think I would like to use this model frequently. Not that much. I found the model unnecessarily complex. Okay. I think I would need support of a technical person to use that model. Strongly disagree. I found various functions of the model to be well integrated. Yeah, that is true. That is again true. I imagine that most people would learn to use this model very quickly. Yeah, that is true. Strongly agree. I thought that there were too many inconsistencies with the model. Cumbersome to use. No. I feel, yeah, I needed to learn a lot of things before I could start using. Strongly disagree. Okay, thank you. Let me just check if anything is left.